Hello, I'm Kyung Yoon. Today I'm gonna present about distributed representations of sentences and documents. And our team members are like this. Many machine learning algorithms require the input to be represented as a fixed length feature vector. And when it comes to text, the most common fixed length vector representation for text is bag of words or bag of n-grams. Both have simplicity and efficiency and accuracy, but there are some disadvantages. For bag of words, it loses the ordering of the words. As above figure, we consider word accuracy as 0 to 1 number in fixed length vector, so we convert the dog is on the tables to that. Second issue is it ignores semantics of the words. For example, powerful and strong is similar word, but powerful and Paris is not similar word. But in this representation, we cannot treat this well. Because of previous bag of words problem, bag of n-grams can consider some semantic through phrase to 0 to 1 representation. But it requires surprisingly large fixed length vector, and the more n is large, the sparser ones are as above figure. And unigrams has 4 1, bigrams has 3 1, and trigrams has 2 1. Unlikely previous work, it proposed paragraph vector. The authors say it can solve the previous issues like semantic similarity or high dimensionality. And in addition to this method can also run without label data. So, we introduced this training process. First of all, paragraph vector score is represent variable length text to fixed length vector. So, final matrix translate input ID to fixed length vector. Then we predict next word given paragraph ID and previous word sequence. Through this process, we can learn word vector representation and paragraph vector representation. In other words, paragraph can contribute to prediction task of the next word without any user's annotated label. So it has several advantages. First, it can represent any lengths input sequence as fixed length vector. Second, this learning process never requires sentence parsing or any morphological knowledge. Last, without any human annotated label, it can achieve state-of-the-art results on these tasks in a published state. And we will explain how paragraph vector can represent context as a fixed length vector. First, we need to know the authors got inspiration from two papers, skipgram and continuous bag of words. This paper just added paragraph vector to its model. Both skipgram and continuous bag of words are learning word vector through sentence word sequence. But two models predict different outputs. Skipgram predicts surrounding words given a word in a context or text window. For predicting input word, cat can represent some fixed length vector through projection layer. By doing this, it can learn and represent cat as a vector. Continuous bag of words model will predict a word given the other words in a context. For example, in the cat sat on sample, we know the in first position and sat in third position and on in fourth position. And we want to know a word in second position. So we train the projection layer by building a weighted sum hidden vector and predicting a word using this vector. Paragraph vector distributed memory model is motivated from these models. Basically, it predicts the last word given current context. In addition to introduced model, it also uses paragraph ID by representing as some embedded vector. The important thing is the cat, sat, words are embedded by some trained word embedding matrix, and the word embedding matrix is shared across paragraphs. So, the, cat, set, these word vectors are same in any paragraph. Another method is paragraph vector distributed backup words, PVDBW, and we only get paragraph ID, but we should predict some text chunk from the paragraph. This process forces the paragraph can be used to classify like that as much as possible. By doing this, paragraph vector can represent related words context, and loss function is made by using conditional probability. It is just probability. For computational efficiency, we take log function. For getting word probability, we usually use footmax as classifier, and experiment tasks are sentimental analysis and information retrieval. Two tasks are text understanding task problems that require fixed-length spectral representation of paragraphs. And sentimental analysis task dataset is movie review dataset. Given variable length review, we should decide whether it is positive or negative. There are two datasets, and one is Stanford Sentimental Tree Bank dataset, and the another is IMDb dataset. The IMDb dataset has some unlabeled dataset, and this method can also use unlabeled data, so improvement can be achieved. Left table is the Stanford Tree Bank sentimental analysis task, and right table is IMDb dataset sentimental analysis task. Previous approach is trying to naive Bayes, support vector machines, skipgram, RNN, and paragraph vector is a concatenation with PVDBOW vector and PVDM vector. All Stanford dataset are one-sentence reviews, so this paper also experiment with IMDb dataset, which has many sentences in a review. And this method can be achieved state-of-the-art performance, as you can see. And another task is information retrieval. IR score is like this. Given a query, we should decide if a document should be retrieved. And this paper is written by Google researcher, and this dataset has been made by their company's search engine. So the task is discriminate which of the trimlet are results of the same query. For testing, we should represent each paragraph as a fixed length vector and check whether these are same or not. Several methods which represent paragraph as a fixed length vector are used as baseline, and paragraph vector can be achieved state-of-the-art performance. So we can conclude this presentation like this. Backup words, which is previous approach, is powerful to represent word vector, but it has limitation to show word similarity due to equality distance between words. And paragraph vector can help several tasks when use variable length text in paragraph and represent paragraph as a common fixed length vector. And PVDM alone have enough performance, but when we use two methods simultaneously, additional improvement can be achieved, thus we recommend. Thank you for listening.